you all can hear me, right? Uh, so first of all, a very brief introduction. Uh, I am Rohit Pandharkar. I head the India business for Headspin, and today's talk is not really about Headspin, but more about how to build apps for the next billion, which means obviously how to build apps that work for the next year of mobile internet users that are coming up online, and how to make sure that your apps and mobile websites work for them irrespective of the rural areas they may be in, the handsets they may be using, and the 2G, 3G, or 4G networks they would be using. So, to briefly introduce Headspin, we are a platform that allows people, especially developers, to experience remote mobile devices, which are real devices on real networks across multiple countries. Now, uh, to begin with the challenge of why it's really important to understand that making your app work across multiple cities and countries is not as easy as testing it in your own office manually. Of course, you would be also hearing more about the typical QA processes from other speakers. Uh, but from Headspin's perspective, the challenge that we are trying to attack and help you with is to make sure that the app's performance across the cloud connections, as well as the CDNs that you're talking to, as well as the device performance while your app is being used, is visible to you, as well as something that gets stored on the cloud in an analytics dashboard and can be shared within the teams. This also includes localization testing. You could also test whether your app's OTP works well or not. For example, some of our large-scale customers who are chat messaging apps or payments apps use Headspin platform to make sure your SMSs and OTP messages are received in multiple countries. So coming back to what are the real pain points while building such an app and why the apps perform badly, is that, as you can see on the screen, some of the largest of the apps today, some of the large private banks who build mobile banking websites and are pouring millions of dollars into it, are still facing issues when it comes to using the mobile website over different networks. As you can see, if everything else loads but the actual account balance or summary doesn't load, it beats the very purpose of building a mobile website so that you make sure that the customer doesn't visit your branch physically but tries to do the transactions online. Same is true with some of the app stores as well, and some of the e-commerce websites, and some of the news content websites, as you can see on the screen. And oftentimes, actually, once you face such issues, as you can see here, the only option available to the user is okay or report, right? It says, unfortunately, the app cannot work. Okay. So this is really going to ruin your user experience. And while you're going to spend several dollars in acquiring every single user, it is essential that you spend maybe a bit of time in ensuring that the performance of the app once it is launched is seamless. Oftentimes, the problems we hear from the developers are that what can I do if a particular telco network's internet or the mobile data plan is very slow? So, which is why Headspin got together with Mobile10X and the Internet and Mobile Association of India to explore how we can make sure that this is not just a single entity problem, right? Either the developer or the telco, but the whole ecosystem needs to look at the problem and see what all really caused these issues. Now, if this is happening, the business case behind improving this, spending more effort on this, is that obviously once you launch an app that is buggy or doesn't perform well, the users are going to rate it poorly, and this is going to directly reflect back in revenues. Some of the issues that cause such problems will be incorrect CDN. Now, I am trying to also explain why just a poor mobile internet speed is not the real cause behind these problems. There could be plethora of issues that even the developer side can fix, and which is what we try to tell most of our developer community, that you should try to see what all are the things that are still in your control and improve upon them. Also, I want to highlight that some of the most popular apps globally today do optimize all these performance parameters, and which is why they get so much love from the users and get highly rated on the App Store. If you see on the left, poor response times from the server side again are not a mobile internet speed issue, but perhaps show that your server is over congested. Slow launch times mean that your landing page is not optimally designed. Maybe you are not bundling together the CSS and JavaScript together, or maybe the SSL times for encryption and issuing the certificates is taking too long. Another issue is high battery consumption. A lot of times we hear from developers that when they first launch their apps on the app stores, they keep getting this feedback that the apps are consuming a lot of battery, and hence the users may not even tell this to the developers and may just flee from the app. Now, how do you detect that all this is happening inside your app? And which is where we come to today's topic of ensuring how to build great apps for the next billion users. Now, how are people testing today, right? There are some legacy solutions, by the way, that people do use, and I do want to very neutrally talk about all the possible options, uh, so that you are well informed about the ways in which you can trace the uh, ways in which you can test these performances of the apps. First is Wi-Fi based simulation. If you are trying to throttle your Wi-Fi from your machine and trying to see if the app is performing as per your expectation or not, using deterministic speed controls, that is one of the legacy solutions people have been using. In such a situation, what happens is you are controlling a very high fidelity network, which is wireless fidelity, and which by default is going to have a very low packet data drop. You are going to end up testing at a local network level, that too on a deterministic speed, which is going to be very different from a reality where, let's say, someone is using an Airtel 2G connection in Chennai and has, say, X% of packet data drop. Now, in India especially, and in multiple emerging countries, for most of the telco networks, on mobile data internet, the packet data drops can be as high as 15 to 20%. In such a case, if you're testing on a throttled Wi-Fi, it is as if testing on a, like watching a HD movie in slow motion. Since the quality is by default high, just by reducing the speed, you're still watching a high quality action happening in a slower motion, which is not really going to help the whole development team. The second one is giant sized SDKs. Now, there are several SDKs out there in the market which say that we will log the user's data and the network performance and the device performance every 3 seconds or every 5 seconds and send it back to the cloud to be shown on a dashboard. While this is a great solution because this can give you the data across all the users that you have, but we should not forget here that this is also a way to tax all your users, not just on data, but also on battery and also money spent on downloading and uploading that extra data. Additionally, why if you could test the same metrics, for example, if the payment is taking too long to happen or the image is taking too long to load, you may as well test it over a relatively smaller sample size instead of taxing millions of your users and also slowing down their performance. Additionally, please remember that these SDKs occupy footprints of up to 3 to 4 or additional MBs inside your app. So if your app itself is sized at 20 MBs, another SDK is going to make the app even more bulkier, making it maybe 25 MBs. So ideally, it should be a solution or a mechanism where you could probably also test the things without getting inside your app. Uh, Now let's come to synthetic monitoring. This is another industry mechanism where developers have been monitoring how the app performs. What happens here is there are server endpoints. So it could be something like payments.xyzbank.com. Now this server endpoint, maybe at port number 443, needs to be monitored for responses. Now, if the response is going to be delayed, let's say during daytime when there are maximum banking activities happening, we need to monitor and see that the threshold of the delays does not cross maybe 4 seconds or 5 seconds. Now, this type of monitoring could be done by synthetically pinging your app or the server endpoint repeatedly, maybe every 15 minutes or every 30 minutes. Now, while you're doing this, what is happening is the real user is not a mobile device on a 3G or a 4G or a 2G SIM card, but is a fiber-based virtual machine. When you are doing this, the fiber-based optic internet connection is going to be much faster and will provide better results than what you would normally see for a real user. And which is where again synthetic monitoring has been losing its charm, and the world is going more and more towards real-time monitoring over real devices. Finally, we come to remote device control. Now, over here, people can access remote devices and which are probably connected to cloud 24/7 and see how the app performs over variety of devices like Micromax, Lava, Carbon, LG, HTC, Motorola, Xiaomi, etc. Now, coming back to why this needs to be done is because the revenues are directly going to be related to your app's performance and qualities. What happens today from a developer perspective is that a developer is always in a hurry, and the launch should have always been yesterday. A lot of you will empathize with that, and hence would understand that a lot of times the bug discovery happens through user feedback over the Play Store or the iTunes Store. Now, how nice it would be if you could see how your app performs and what all network activities and device parameters are taking place while a real user is using your app in, say, Chennai over a Motorola phone on an Idea 3G network. How can you do this pre-launch? The only mechanism for you to do this today would be to actually send a volunteer in that city who uses that phone and has that network plan or goes and buys such a SIM card plan and tests this. Even when he does it, he would be able to give you some user experience feedback that these things worked, these things didn't work. But how do you want to ensure that I want to know that a particular server endpoint was delayed beyond 5 seconds for a particular response, or that the OTP got lost in the network because of following 1, 2, 3 issues. Now, if you have to figure out how to do this, you can use a packet sniffer or a platform that lets you track the entire network traffic. So I want to just show you a mechanism, and I'm trying to be as neutral as possible because the talk is more about the network side of testing and its needs rather than Headspin as a platform. But we are sure that since we have this partnership with Mobile10X as well as T-Hub, you are all welcome to use the platform and then see the network testing for yourself as well. Now, here is a sample of how pre-launch testing could be done. You can see that there is a list of devices from Tokyo, Singapore, Dallas, Los Angeles, etc. over different telco networks like Singtel, Verizon, Sprint, etc. And you could be accessing this from your own test phone in your own office while sitting on your chair. So the way it works is we help teleport your phone in hand and its network to a real phone in, say, Chennai over a Vodafone 3G network, or in Gurgaon or Airtel 4G network, and so on. How we can do this? I'll quickly jump to a slide where you can see that there are these real phones and real devices with SIM cards for which we manage the payment plans and make sure that these phone device farms are located in real cities within India as well as globally, where people can reroute their network traffic and have access and test the apps over real locations. Now, having done this, once you reroute your network traffic to these devices, you are going to see a rich dashboard like this. So I will come to a sample case study now after I explain what is really happening at the background. So while you tested, let's say, your app on a Singapore network, here what is happening is the touchscreen, the microprocessor uh, of your phone in hand in your own office is getting married to the network or the SIM card of a real phone that we have placed in Singapore, which is on Singtel network. So if you after this go back to the home screen and open up your own app and actually try to use it like just a normal user, all the GET requests, the HTTP requests, and the responses are actually getting rerouted through a proxy server, as you can see here, to the Singapore phone and the Singapore SIM card. The ingress and egress starts getting locked from then and there in reality from the Singapore location. So there are no delays in the dashboard of analytics that you see. At the end of the test session, you will see a very rich dashboard like this. Now, this brings us to the real case studies. I am going to share with you a few real life apps and how their performances can be analyzed and optimized for improvement using such a network traffic dashboard. So let me switch to a real dashboard over here. As you can see, this is from another app uh, that is already on the Play Store. Here we are connecting to Noida Vodafone 3G network, as you can see on the screen. And this is, by the way, on the cloud, and each of your team members can share this link among themselves. And the test has to be done just once, and post that there will be single session to be shared with everyone else. So as you can see, there are different such sessions that you can conduct. So this one is from Chennai Airtel network. As you can see, whatever is the real experience of the user uh, could be seen in the video. And over here on the left side, as the orange reference line moves, you can see that while there was buffering happening from the app screen, what all network activities were happening in correlation with that. As you can see that there are multiple activities that got started, and which is why the response times for those perhaps are higher and are leading to this delay in loading of the app. This is not to criticize or praise or comment on any particular app, but this is just a sample for you to see and correlate the video with the actual network activities. Now let me explain how to look at and interpret the different network statics. Over here, you can see that the average wait time for this app was 595 milliseconds. Now you can see most of the activity is happening within half a second or less than half a second. So it becomes important that you know how is the distribution of activities and resources happening inside your app. Here we show that a lot of times people say that there is not we can do about the network activities. If the network internet is slower, it will just take longer to load, and hence there is only this much of testing I could do. But this single pie chart will debunk that myth. And you all today, after this talk, should take this one point home with you, is that the total download traffic time is probably like 10% of the overall pie chart of activities inside your app. So the blue pie chart area that you are seeing here is the actual data reception time. So if you are saying that my app is slow because the internet connection took longer, that is not the right way to explain it, because there is so much more happening on the network side, and which is why uh, perhaps it makes sense to devote more time to see what happened. So this is around 20% of time, which is the orange color, going into the TCP connection. Another 20% of time is spent in encrypting the whole data. And all of this time is actually wait time to hear back from the server. As you can see, this is the server side delay, and over congested servers can cause such longer times to respond. And this is not just for any particular app, but these statistics hold for most of the apps. Even if you analyze your own app, you will start seeing similar results. And that is where you may want to dig deeper now. As you can see, this test was conducted over Chennai Airtel 3G network. And the average download speed was 173 kbps, which is pretty good by Indian 3G standards. I just want to show another sample where you can see how the speeds drastically vary. Now here you can see there's Kolkata Airtel 3G, and the speed received here is 21 kbps. So, we all should keep in mind that when we talk of 3G mobile data connections in India, they can vary from as much as 21 kbps all the way up to 175 or perhaps 300 kbps in the best case. So when you design your apps, you should ultimately design it assuming that there will be some user who will be using at a 20 kbps connection and another one at a 300 kbps connection. While there is all the talk around India migrating to the 4G networks, I hope you all will agree with me that while already 3G was being touted as a radical difference from 2G networks, the real 3G networks in India today are at this speed. And hence, there will be several years until we really get to a speed levels across India where anyone can start buffering high level video of great quality immediately. Now, in all this case, if you were to analyze what is really causing trouble inside my app, uh, here is a brief example of how to know what is going wrong. So there is a machine learning bot that will automatically analyze your network traffic and let you know the duplicate requests. So for example, if there are any duplicate requests or the same requests that your app is sharing, uh, you can automatically figure them out using machine learning. Additionally, if there are any slow downloads happening, they will be automatically identified. About to conclude and go towards the end of the talk, I want to briefly also show how different domains inside your app can be having radically different performance. For example, if I go to this particular SDK, you can see that the time taken for SSL connections is way longer compared to any other domain over here. Additionally, if I go to something else, again, if there is no SSL protocol, the time taken for just the TCP connection would be really high. So I want to leave you today with the thought that what happens inside your app is something that is beyond intuitive imagination. And like you can see here, the connections pool inside the app can be shooting up to 2022 size and remains so forever. And hence, one could optimize the apps for a better performance if all these parameters were first visible to you, and then you knew what all is creating problem and does improve on the speeds. So that's all from my end. I hope you got a glimpse of how the network performance and geography based location performance for apps is really crucial. And if you have any questions, I'll be happy to take them if you have time now, or you can contact me offline at my email ID rohit, ROHIT at headspin.io. Thank you.